We're going to talk about how to write a balanced chemical equation from laboratory data, and we're going to use the reaction between copper and silver nitrate solution that you may have done in a laboratory. The reaction that you saw, you placed massed copper wire into a solution. The solution was made with a massed amount of silver nitrate and distilled water. So you knew how much copper wire you started with, and you knew how much silver nitrate you were going to react. After some time, you saw crystalline silver metal on the copper, and I say blue copper 2+ ions. They're not blue, but they look blue in the water. They absorb light so that they appear to be blue. And it was dissolved in the water with the remaining nitrate ions. So if we write a skeleton equation, and that's an equation that just tells us what reacts and what is formed, we have copper, metal, reacting with silver nitrate, silver plus and nitrate minus, to form silver metal and copper 2+ ions and nitrate ions. The nitrate ions are unchanged. Then you filtered the silver and found the mass of the silver after it dried and the mass of the copper remaining so that you could calculate how much copper was used. One student group had the results that you see here. 2.01 grams or 2010 milligrams of silver nitrate gave them 1.2 grams or 1200 milligrams of silver metal, and they used 0.39 grams or 390 milligrams. Now, the reactions that we use, chemical quantities, are counted in moles or millimoles. Therefore, we divide by the molar mass of silver nitrate, about 169, and we got 11.8 millimoles of silver nitrate used, and 11.1 millimoles of silver by dividing the 1200 milligrams by the 107 plus milligrams per millimole of silver. So there's our millimoles of silver nitrate and silver. And then we divided the 390 milligrams of copper by the 63.54 milligrams in a millimole and got 6.13 millimoles of copper. You will get similar quantities or similar ratios of quantities in your reaction. Now, if we move those same millimole numbers, we can calculate what we call mole ratios. This is going to be used to write the balanced chemical equation. The ratio of silver nitrate to silver moles, here to here, is 1.06, very close to 1. The ratio of silver to copper moles is 1.92, very close to 2. The nearest whole number ratios for the silver nitrate and silver, 1 to 1, and for silver to copper, 2 to 1. 2 moles of silver nitrate per 1 mole of silver. 2 moles of silver, 2 moles of silver nitrate make 2 moles of silver, and 2 moles of silver can be gotten from 1 mole of copper. The nearest whole number ratios we show there, and what that means is 1 mole of silver nitrate will give us 1 mole of silver. That makes sense, doesn't it? Because 1 mole of silver nitrate, AgNO3, contains 1 mole of silver. You certainly couldn't get any more out than 1 mole of silver. And 1 mole of copper has given us 2 moles of silver. So the equation must be, and we use the coefficients of the equation to be the number of moles in the mole ratio. 1 mole of copper reacts with 2 moles of silver nitrate to form 2 moles of silver and 1 mole of copper 2 nitrate, which we would write CuNO3 taken twice. Now, if you took class data, you probably got millimoles of silver nitrate and can put that on the horizontal axis, and millimoles of silver metal and put that on the vertical axis. If you do that, you can see here from this plot, and 0, 0 is a point, you can see from this plot that the best straight line goes through right like this, And the slope of the best fit line here, 0.936, is very close to 1. So for the class, just as for this student, 1 millimole of silver nitrate will yield 1 millimole of silver. When you do the same type of graph for silver versus copper, and there's some really weird numbers here, here, and here. But even if we have those numbers, we get what looks like a straight line. The slope is now very close to 2. It's 1.9388 for this straight line, so that as you can see here, 1 mole of copper produces 2 moles of silver, 2 moles of copper produces 4, 3 moles produces 6. So 1 millimole of copper is producing 2 millimoles of silver product. This verifies our balanced chemical equation, which says 2 moles of silver nitrate react with 1 mole of copper metal to form 2 moles of silver and 1 mole of copper 2 nitrate.